Alright, so I want to quickly discuss why you should not write force equals constant acceleration. So, yes. Okay. Reason number one is the first law dictates it. Why is that? The first law states simply everybody preserves in its state of motion sorry, not state of motion, state of rest. I don't know how to read today. Its state of being. That's better. At rest or of moving uniformly, straightforward, except insofar as it is compelled to change its state by forces impressed. Okay. Now, translating that into basic English, it means the body either stays at rest or a body is at a constant velocity unless compelled so by a force. Okay. In other words, this situation is happening in the absence of forces, period. So, to explain that, here you go. Here's a NAS. Something like that. It could be at rest or equals constant. It can be at rest or with the constant velocity. Okay. As we know, constant velocity means no acceleration. So the first law dictates that unless there's a force, it will either be at rest or at constant velocity. And this is a very important thing. So the first law allows us to have motion without a force. That is to say, motion can exist without a force, and that's what's happening in the second situation when velocity is constant. Okay. So, what happens when there is a force? That's where the second reason comes in. Okay. That's the second reason here. The second reason is the second law is written in such a way that does not define the force. Okay. So it says the following: a change in motion is proportional to the motive force impressed. The key concept to look at here is a change in motion is proportional to the motive force impressed and takes place along a straight line in which the force is impressed. Okay. So the concept of change in motion means is the key thing. Why? Because the first law dictated what happened without a force. So second, what happens when there is a force? It doesn't define what that force is, but it says what happens. There is a change in motion. And I'm quoting from Principia. I'm quoting directly from Principia, which is Newton's book. And this concept of motion is defined as a body's, of course, mass times its velocity. You can read it in definitions page. And he defines what this notion is. It's a quantity of matter and velocity jointly. Okay. And then I will quote it here directly from definition number 2. The quantity of motion is a measure of motion that arises from the velocity and quantity of matter jointly. Okay. So that comes from definition 2, which is in Principia. All of it will be on resources page. Okay. It's proportional to said force. Now, if I'm looking at this definition, if I'm looking at the second law, I'm defining what a change in motion is. I'm not defining this side. Rather, I'm defining this side. So the logically solution here is to not put the constant of proportionality on the side of mv, but rather But logically, way to put it would be over here. So in order to eliminate this, I would have to say F times delta T is mv, which is closer to what Newton was intending by the second law. But still, that leaves us with the situation. Okay, if Newton was talking about impulse, how did we get the law as we know it today? Okay, well, simply put, divide by time and divide by mass, and you'll get it. Okay. So the second law is not defining what that force is. As a matter of fact, force isn't defined mathematically, typically speaking. But it's something to consider that Newton's law would be V divided by delta T is equal to sigma F divided by M, thus implying A equals sigma F over M. That's a vector, obviously. Now, why is that important? Because it maintains the consistency of Newton's original statement, which is a change in motion. That's what acceleration measures, obviously, the change in motion, not the change in position in varying time like velocity does. But acceleration measures the change in motion. So that's reason number 3. Reason number 3 is acceleration is consistent with Newton's acceleration is consistent with Newton's wording. That's reason number 3. The idea of a change in motion is talking about acceleration versus acceleration better expresses it than defining it as a force. Okay, so better to say this. This is a better statement than this statement here. And of course, the fourth reasoning, and I'll stop at 4, the last reasoning here is that Newton himself used it. Okay. If you go in book 2, if you go into book 2, theorem 19, as soon as I find it for you, will be good to go, even though I have it memorized how he wrote it, but it's like I don't like to quote things wrong. So theorem 23, theorem 22, theorem 19, proposition 24. Right here. Okay. So Newton himself used this form. And how exactly did he use it? Okay. He states it in book 2, proposition 24, theorem 19, next page. He states, for the velocity that a given force can generate, in a given time in a given quantity of matter is as the force in time directly and matter inversely. Right? So the force and the time directly and the matter inversely. So that may sound very complicated, but mathematically it would look like this. Velocity is of course proportion. The velocity that something can give and generate proportional to its force directly, matter inversely, and of course time directly here. But again, this would have to go over here, logically speaking. So V divided by T sigma F over M. Right. So you can see here, the force and the time are directly, and this matter is inversely to it. So, which of course simplifies lastly to A equals sigma F over M. So in conclusion, right, we said what are our reasons? Reason 1 is the first law dictates. Of course, reason number 2, going right, is that the second law does not define force. The third law. Third is because acceleration is consistent with Newton's wording. And lastly, and of course, last reason is that Newton used it himself. Of course, even if not directly stated as such. But here's the thing. Even though Newton used this form to solve pendulum problem for the fourth one, the concept of what he knew still applies. So, therefore, this is the better form